Foundations of Amateur Radio. The amateur community is nothing if not entertaining. Look at any discussion about a mode like FT8 and you'll discover people who describe it as the dehumanizing end of the hobby. In the same thread you'll find an amateur who's been licensed longer than I've been alive who welcomes it using words like revitalizing, more active and the like. If you're not familiar, FT8 is one of the many weak signal digital modes that gained popularity over the past years during the most recent solar minimum, when long-distance HF propagation was challenging. That example discussion was about the visible end of a mode like FT8, but there's an often overlooked, all but invisible aspect of these modes that is much more significant, namely the popularisation of signal processing in software. In many ways, amateur radio is more about receiving than transmitting. This might not be obvious, but what's the point of transmitting if you cannot receive? Using software to do the listening makes for an interesting evolution that might be hard to grasp if I start digging into the fundamental algorithms that make this happen. Instead, let me describe a process that is easier to explain. Imagine that there's a piece of software that knows how to decode digital signals. As the user of that decoding software, or decoder, you send audio into one end and call signs and grid squares come out the other end. How it does this isn't important right now. We measure the quality of this decoder by how many times it correctly does this. In other words, how many times a correct call sign and grid square comes out. The decoder can be improved by changing the way that the decoding process works. If the number of correct call sign and grid squares that come out increases, the quality of the decoder is improved. Now imagine that the decoder spits out the call sign 7 November 5 Echo Charlie with the grid square Oscar Fox 78. This particular combination emerged as a whisper decode on the 10th of December 2022. It was reported by Alpha Alpha 7 November Mike as a 100-watt signal, 14,882 kilometers away on the 40-meter band. The signal report was minus 30 dB. If you know where Oscar Fox 78 is, you'll immediately spot a potential problem. If not, I'll help you out. Oscar Fox 78 is located near Perth in Western Australia. It's unlikely that a transmitted call sign in that part of the world starts with anything other than VK6. Mind you, a weather balloon with an odd call sign could theoretically be overheard in that location, but I've not yet heard of a 100-watt transmitter on 7 MHz that someone hung from a weather balloon. Another problem is that 7 November 5 Echo Charlie is a call sign that appears to be Japanese. It starts with 7 November, which is part of the Japanese call sign block, but the next symbol is the number 5, and, at least according to the research I was able to do, is not actually a currently valid call sign. The prefix 7 November 4 is allocated to the Kanto region on Honshu Island, the largest island in Japan. 7 November 5 doesn't seem to be valid as a prefix. Ironically, that call sign will now exist on the internet as soon as this article is published, but that's a whole other problem. Either way, the chances of the combination of the call sign 7 November 5 Echo Charlie with the grid square Oscar Foxtrot 78 is unlikely to be correct. It gets even less likely if you consider that the call sign was reported only once in 15 years, and over 500 million whisper decodes. I checked. That means that if you updated the software to ignore that particular decode, you'd have improved the decoder by removing an incorrect combination. You could keep doing this by checking call signs against grid squares and against allocated call signs, and you'd have made a higher quality decoder. Before you start arguing that this isn't fair, it's exactly the same process as the supercheck partial list does for people operating in a contest. The idea being that if you only recognize known contesting call signs, you've got a better chance of making contact. Think of it as a way of filtering out potentially incorrect call signs. It still leaves the operator having the option to ignore the suggested call signs and listen to what's actually coming in. I realize that this is not how you would realistically improve a digital signal processing decoder, but it's an example of how changing the software can change the quality of a decoder, and that was the point of this example. In reality, you'd attempt to discover how this decode happened and what caused it to be wrong. If you want to consider a more signal-centric example, consider a decoder that starts with the first attempt at making a decode. With a single decode, it can then remove that known signal from the original audio and start another decoding cycle. You can repeat this as many times as you want until you end up with gibberish. Essentially, this is an example of how a modern decoder can improve its performance. This is why signal processing in software is so powerful and important, and why FT8 and the rest of the digital firmament are here to stay. I should point out, for those wondering, FT8 and Whisper are examples of simple messages, but there's nothing stopping us from using digital messages like this to exchange little bits of audio, or video, or something else. It's how mobile phones work today, and at some point amateur radio is going to extend the envelope and come up with the next thing. It always does. So, FT8, it's changing amateur radio, but not because we're glued to a screen having our computer talk to another one, but because it represents digital signal processing in software, and it's just the beginning. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.